Ready? So now we're going to talk about combined uncertainties. Okay, so things are going to start adding up. So we've explored how each measurement, right? No talking now, please. Each measurement has an uncertainty or a margin of error. And this is due to the limitation of the measuring device, also known as the precision. What happens if you combine measurements, right? What about when you keep removing, like when you keep removing an amount from a larger batch? What happens then? Okay. And so here's in summary what we're going to do. The total or combined uncertainty is the sum, right? The addition, if you want to write it, addition of all uncertainties that are present. Okay? This is due to the fact that something is measured and added to the total. The uncertainties also increase. Okay, the more you measure something and keep adding it to a pile, the uncertainty actually increases as well. The margin of error increases because something is measured repeatedly. Okay, something is measured repeatedly. It can seem insignificant in most sectors, but it is very important to consider in some industries. For example, a plane weighing all the items being loaded on board of the plane, okay, the pilot needs to take into account that the actual loaded weight may vary significantly. And this is, right, so the actual loaded weight will vary significantly, and this is due to the combined uncertainties. Another example would be a gas station needs to be aware that the amount of fuel remaining in their holding tanks may be higher or lower than expected. Every time someone draws fuel from the car, right, a measurement is taken, and each time the uncertainty increases. Because the pump is technically measuring. Every time you're drawing from it, it measures, and then it subtracts from the total, right? But every time the uncertainties actually increase. So here is the first example I want you to consider, okay? There's 3 pieces of fabric that are being sewn together, okay? Determine the precision and the uncertainty for each piece. So this is a review from last week or Monday, okay? You've got the 3 pieces here. If you sew them together, what are you going to naturally do to all of these amounts here? To get the, you add them, right? Because you're combining and making one long piece. But, and so what I want you to do is I want you to, for each one of these, figure out the precision. And then for each one of them, we're also going to figure out the uncertainties. Okay? What's the precision? Notice that all of these are in centimeters and they all have 1 decimal place. So in this particular example, every single precision is exactly the same. It's 0.1 of a centimeter. And the uncertainty is also going to be the same, which is half of 0.1. That's 0.05 of a centimeter. Okay? So we've completed part A, that's done. Calculate the total length and the combined uncertainty. So we want the total length and the combined uncertainty. So let's put a line down here. We're going to add this up. Okay? So you can use your calculator or you can just use mental math. But I'm going to go 5.4 plus 60.3 plus 30.1. And that's 95.8 centimeters. Then I want you to ignore the precision in this particular case. We don't want that. We want the combined uncertainty. So here's where you have a choice, okay? If they're all the same, you can just take the uncertainty and multiply it by, we have 3 of those, right? You just multiply it by 3. Or you just add them each individually, whatever works for you. Okay, so if they're all different, of course, you would want to add them individually. but this is the combined uncertainty. Okay, so this answers question B. And the most common mistake is that students add up the precision and they tack that on here, but it's not, right? You have to add the uncertainties, okay? And here I just want to revise that example that I used last week with my ruler, right? So if you have this ruler that I made, I'm going to zoom out one. Let's use this ruler, which is not precise, right? This one is not a very good ruler to use. But if I measure this calculator, what is it approximately right now? We have to pick between one of these two. What would we pick? It's closer to 8, so technically this calculator would say 8, okay? And then I come along and I measure the same calculator again, and it's 8, and I'm putting them right next to each other. Every time we're measuring with this device, we're off. We're actually off. It's not 8, right? And so if you were to stack calculators side by side like that, every time you do that and you measure one individually, that uncertainty that you have keeps building up, So this long piece is going to be off even more so than my original one-piece calculator, right? Calculator is not a very good example to use here, but I hope you get that illustration that you add no matter what, okay? You add no matter what. So this is the measurement combined with the combined uncertainty. C. Oh, yeah. Yeah, that's already good. C, determine the shortest and the longest possible combined lengths. Here you just basically use this. So the longest would be 95.8. So that measurement there, you would add the combined uncertainty. Shortest would be what? 95.8 minus 0.50. And so what do you get here? You just grab your calculator, which I now misplaced. I'm doing the shortest part, right? 95.65. And then you want a 95.8, sorry, plus 0.15, 95, okay? So that's how you do the longest and the shortest, right? So we have that. So sometimes the province will only ask you for one or the other, okay? Yes. Yeah, go ahead. Okay, one or the other. So if they ask you what's the longest possible piece that you could have if you combine them all, you would just state 95.95. If they ask what's the shortest possible piece that you could have if you sew them all together, it'd be 95.65. However, it all comes back to, this is the important part, each piece that we were considering has its own uncertainty, okay? And when we sewed everything together, we had to add all three together, and the same thing happened with the uncertainties. We combined them all. And then from here, we could say, hey, it could actually be way longer than that or way shorter than that, okay? Depends on what is the question asking you, what's the province asking you, you have to act accordingly, okay? Let's go to 26 here. Let's try another one. Moses has a bucket of water with 20.5 liters in it. He needs to draw some water for some plants using a smaller jug that can hold 1.2 liters. Why is it Moses and then Junior? I don't know what happened there. If Junior draws 3 jugs from a bucket, how much water will be left in the bucket, including the uncertainty? Okay, including the uncertainty. This is important here. Highlight that part. So for A, what's happening here? We've got our big bucket of water, and we're drawing 3 jugs, like that smaller jug, we're drawing 3 of those out of that big bucket. So I hope you would understand that this is what's happening, okay? Okay? So let's do this part first. 20.5, you can go minus 3 times 1.2, like just do it that way, or subtract 1.2 3 times. You're left with 16.9 liters. But that's not good enough in this case, because they also want the uncertainty, the combined uncertainty. Okay. So what's the first step you should take? Is figure out the precision of everything that's involved here, everything. So we have the big bucket. What's the precision? 0.1 liters. Uncertainty is half of that. That's 0.05 of a liter. Okay. Is it fair to say that the jug has the same precision and uncertainty? Yes, they all have 1 decimal precision. So you can go ahead and just copy paste all of it like that, and the uncertainty is going to be the same as well. Okay. In this particular example, I'd never asked you to figure out the precision. You're not going to get a mark for it here because it didn't ask for it. So I'm gonna ignore this for now. I'm going to just cross it out lightly. Don't cross it out so you can't read what was there. But we're going to go plus or minus. So instead of having a number down here, we're just going to say plus or minus. And then we're going to add up all of the uncertainties that were there. What's the fastest way of doing repeated addition? Just multiply it. And in this case, it's 0.2 liters. And I want to make a note here. We add, and we always add. Okay? When it comes to the uncertainties that are present, we always add them up. There's never a subtracting scenario. The only time you have to determine do I add or subtract is the actual measurement. But because I'm drawing water out of the bucket, it's implied that we're subtracting, right? So this is really what the question wanted. Okay. I would like you to at least know you could have done this differently. This is a lot of work, in my opinion. You could have done it a lot faster. You could have gone 20.5 liters plus or minus 0.05 minus, right, 3 times 1.2 liters for the first part plus 3 times 0.05 liters as well. So that would have been another way, right? 20.5 minus 3 of these, you still get 16.9 liters, plus or minus. Here you have to add them all. So 0.05 plus 3 times 0.05, it's still 0.2 of a liter. That doesn't change. Okay. So you can set up the work, you can show your work however you want. It doesn't have to be like this, but this is my preferred way of doing it because then you can see what's happening, okay? Can we cross one of these out here? Let's just say maximum, like get rid of the minimum, because sometimes students think they always have to do both. We'll just say imagine the province says, what's the maximum amount left in the bucket? What is the maximum amount left in the bucket? So you should be able to say, let's say you get this wrong, A is wrong. You should still be able to get B right, which is basically just taking the amount, right, plus 0.2. And if you add these up, 17.1 liters is your answer. Okay? If Junior needs 17.5 liters to water a tree, will he have enough water? Okay. What is this is the max that you can possibly have according to our, so the answer is no, since the max amount left in bucket is 17.1 liters. Okay, so the reasoning here is like, no, the maximum you would possibly have is 17.1, so 17.5 is not possible. Okay. All right. I feel like at this point you should have a pretty good idea of what is expected. So I will ask you to try this one right here. Still copying, it should be visible. I would like you to figure out the total weight of all of the boxes that are combined. If you were to combine them all together and put them in a plane, for example, or a truck, what is the combined weight? So obviously you'd have to add these three, but what is also the combined uncertainty? Okay, guys, combined uncertainty. So I would like you to do this. Break every single one down, have them right next or stacked like that. That's 2 kilograms, sorry, my bad. And 1.45. You're gonna need to figure out the precision for each one of these and also determine the uncertainty for each box. Like each box has its own precision and its own uncertainty. Fill this in. And then last but not least, you're gonna have to do something with these numbers and you're gonna have to do something with these numbers. That's for part A. And if you wanna wait till we're done, till I go over it to do part B, that is fine, okay? Do this right now based on what you see here. Just give it a try, right? If you get it wrong, there's not a big deal, just use a pencil. See how you do. Right, the precision, and it doesn't matter which order you did them in, but the precision for this one is 0.1, okay? Because it's just a decimal there. What's the precision for 2 kilograms? It's a full kilogram. That's right, it goes up by a kilogram at a time. Not a very precise device that has been used, right? The precision for this one, it's 2 decimals, so you just make sure you have a 2 decimal answer where that second decimal is replaced with a 1. So now slice it all in half. Half of that is 0.05. Half of 1 is 0.5. Half of this is 0.005. Okay? So now we add these up, right? For this, if you add that up, we get 19.95 kgs. We go plus or minus. Do not add up the precisions. You add up the uncertainties. If you add them all up, you get 0.555 kilograms. Okay? So this is what the question wanted. Okay? So for your notes, right, you say you combine, you add them. And of course, we added these as well, right? We added all the weights together of all the boxes to get our 1995. What's the maximum and minimum combined weight that the boxes could possibly have? To get your max, you simply add these two up. And just make sure you use your calculator. I would strongly suggest, because if you get it wrong, at least show the work, right? If you get it wrong, you would just lose half. Minimum is 19.395 is the, oh, I'll show the work, sorry. I just told you to show work. 1995 minus the combined uncertainty, and that's 19.395. Okay. So this answers B. That's how you do that one. Go ahead. Next, let's go to 27. Let's do a few different cases here. I want you to try and read this one here, Marcy the Carpenter, and also try D, which is right underneath, okay? As well as E if you get to it, right? So try reading that, this whole page. I would like you to try this whole page, okay? Before you do anything else, you try this and see if you can, at this point, read and understand what needs to happen. Okay? We'll go on to the next part. Okay, Marcy's a carpenter. She's installing sheets of plywood. She reads the measurement as 225 by 1.3 meters long, right? They were both measured by someone else. What's the length of each plywood in the form measured value plus or minus uncertainty? Okay, so they want you to state each and every one like this, okay? Plus or minus the uncertainty. So let me show you this loop. I'll say that the precision is 0.01. And that's what you're going to feed into it. What's half of that precision is 0.005, right? That's what you would put in there. And then the other measurement, the 1.3 meters, you're gonna go plus or minus. Just that one has an uncertainty. Before you go ahead and do that, you go precision is 0.1. Therefore, to get the uncertainty, you're just going to split that in half. That's 0.5, meters. So these are both measurements with their uncertainties, okay? And it's all based off of the numbers, okay? B, what's the total length, including uncertainty, of the two sheets as they're placed end to end? So they're combined, okay? You want to combine them. So here it is. It's you stack them like that. Same with the other one, the other sheet. And you add them up. If you add it up, you get 3.55 meters plus or minus. If you combine this, you get 0.5. Sorry, is that right? 0. I made a mistake here, right?
Excuse the interruption. Michael Lavallee, back to 53, please. Michael Lavallee, back to 53, thank you.
My bad, guys. Half of 0.1 is 0.05. Okay? 0.05. So I made that mistake. Let's fix that here. So if we add these two, you get 0.055. Okay? There you have it. So this is the combined, the total length, including their uncertainty. So you want to combine both of them, the measurements and the uncertainties if you do that. Okay? C, what's the longest and shortest possible lengths of the pieces combined when placed end to end? So longest would be 3.55 plus 0.055. and that gives you 3.605 meters. The shortest is 3.55 minus 0.055. That's 3.495 meters. Okay, so there you have both of them. Based on this, we figured that out. Okay? So that's how you do that part. Break it down. Make sure you know how to do precision and uncertainty. Now this D and E, let's do that one together. You want 10 pieces measuring 1.3 meters end to end. What would be the combined uncertainty? Make a note here. Only asking for uncertainty. They don't care about the combined length, okay? So what's the uncertainty for one of these? We already figured it out earlier. It's 0.05. 1.3 meters has a precision of 0.1, has an uncertainty of 0.05 meters, okay? So 10 pieces, hold on, 0.05, right? You just multiply these two together. And so the combined uncertainty would be 0.5, right? Meters, 0.5 meters. So basically, we just took this and we multiplied it by 10, right? And so it basically just shifts over the decimal one place. This is all it was asking for, just the combined uncertainty. So you focus on the uncertainty of one piece, multiply by 10 because they're all the same, right? What about if you placed 50 pieces together of the piece that measured 2.25 end to end? What's the combined length and uncertainty? Okay, it's asking for length and uncertainty. So in this case, you got to go 50 pieces times 2.25. Let's do that first. That's 112.5 meters. And we're going to go 50 pieces times, what was the uncertainty for this again? Let's just look up there. It was 0.005 of a meter. So we multiply that by 50. And so that's 0.25 meters. So you've got the combined length and the combined uncertainty. So you're just going to write it like this. It wants the combined length and the combined uncertainty. So in this case, it was just a matter of multiplying each, the measurement and the uncertainty by 50. You've got them both. Now you just have to write them in this format to get that right. All right. I think I've given you enough examples. I was going to give you an AC, but I think I'm going to hold off and I'm going to ask you to practice these a bit more. So from 28 to 31, okay? Yeah. Go ahead. 28 to 31. And just make sure that you know